All right, tonight we're going to look at how we actually set up our OnShape documents and how we organize the robot construction and design inside of OnShape. So we've gone over how to actually make parts and assemble things and all that. But when we expand out and look at the bigger project of how do we get an entire robot fully designed and operational with multiple people working on things, there's a lot of individual pieces and parts to it that make it work for us. So this is what we kind of established when we worked on designing Gamma Ray. Then there's some other things that we've added in and are going to be ready to do in our next full robot in 2022. So this is kind of the context of what we're going to look at tonight. We're just going to describe a lot of it. But these are all the pieces of it that allow us to make the robot, then kind of make our design process run smoothly. First off, there is a OnShape learning process for a lot of the individual tools and techniques we're going to show. So if you want to get more direct hands-on and see exactly which buttons to hit when and how everything works specifically, this is a great way to go through it. It walks through exactly how to actually do a lot of these things. They have the full learning pathway on these 3 different types of some of the different things that we use to make our robot process work, and they're going to have activities and everything for you all the way through it. So I highly recommend doing that. It has a lot of really nice stuff, and you can go through the videos pretty quickly. You don't have to listen to all of it, and you can speed them up and skip through. But it definitely is a nice way to get comfortable with a lot of the individual tools. And this presentation will go over a lot of the concepts, but not necessarily the exactly how to do everything. So the idea with top-down modeling is that we're going to use a primary document that's going to hold a lot of the information about the entire robot. And then in separate documents, we're going to use that information to make the actual robot parts and make sure everything fits together and make each individual mechanism. And so if we do it all right, if we update the sketches inside that primary document, or if we update different parts of that primary document, all the other mechanisms are going to update and change the way we want them to. So it keeps everything in a nice cohesive unit. It makes sure everything in the robot's going to work together, and we can keep using all aspects of the robot, and multiple people can be designing, and it just kind of all works. What this means is we're going to have multiple documents. So in our OnShape folder, what it looks like over here, and we can actually see the true one. So we have this folder that is Gamma Ray. The 0 in front of it just helps us put it at the top of our folder organization. So this will get off of 0 once we're making a new robot. The 0 robot is whatever we're currently working on. In this folder, 0 is our main or primary document of the entire robot. And then each mechanism has their own document going down, and they'll all be linked together. And we even have one for electronics and any of the auxiliary stuff that gets mounted around the robot that we still need to get CAD'd in. And then the rest of them are our normal mechanisms that will normally have a design leader for on our team who's in charge of or responsible for actually getting all of that CAD, making sure it's all getting done by the people who are working on it. Versioning is a really big deal in OnShape and an even bigger deal in this process to make sure it all works, because to actually be able to link the documents together, you have to have them at their current version. So if somebody edits one of the mechanism documents, we don't see it until they make a version of it. So to make a version, we use our version toolbar up here at the top, so we can create a version. We can also see all the past versions. It gets a little crazy. So this is version 141 of this robot right now. It's very possible you're going to be versioning 4 or 5 times in the span of a few minutes, just spitting out versions if you're going back and forth between documents and you just see how their updates affect each other. And it doesn't affect anything to just make a new version. So I can just hit create version right here, hit create, and it's fine. And you can just do that over and over again. We don't really need to put too many comments in on any of just the minor versions that we're doing. It's not a big deal to put to tell them what they are, or to do them or name them in any way. When we do create version, if there's some big change, you can definitely go in, put a description, put a specific name in there if you want. But for most of the time, if it's just a minor update, you can just leave the number and move on. But we're going to be doing that for like all of the documents pretty much constantly as we edit. If anytime you do make a change, even if you edit anything and you leave, you should always just like make a version when you're. It's almost like saving your work. OnShape saves everything for us all the time, but just like making that little version allows everybody else. It'll like let everyone else in other documents see the change has happened, so they don't have to go and check or anything. There is a tool called pin reference that lets us lock versions if we don't want certain things to update. We shouldn't really be doing that for documents we control. It is useful for some of the things, like if we're using things in like the MKCAD CAD library that other people are owners of those documents and we're just like importing them and using them. It's useful to pin reference, so if there's like weird updates, things that we don't necessarily want to happen, we can make sure we're using the correct version and the version that we want of a certain external document, and it won't mess up it doesn't mess up any of the windows or anything where it has like an update all. So if you click up here, you can update all of the documents. So we have a couple of ones that may need some updating. So if I click this, it'll let me update all of those different documents. But like MKCAD wheels, it's not it. Oh, it might actually let me update that. We'll see, because that is a full version update. So we can go in and get all of these changes and they'll propagate into our full assembly. Slowly, but it will. Okay, we'll come back to that. When we actually create all these other mechanisms and when we're like interworking between multiple documents, it's very useful to us that we keep like the relative positions of the parts in the same space. This isn't necessarily important if you're making like a single part that we're going to import into the robot, if we have that in a part studio. But when we have an entire subsystem, it becomes more important. So if we look at, let's say the indexer, I think indexer should work for this. The indexer part studio, when it loads, we'll be able to see where the origin is, and it's going to be in the exact same spot that the origin of the document for our main robot is, and for all of our assemblies. So when we actually go and insert them into an assembly, it automatically, OnShape knows where the origin is, and it automatically puts the part in the same place in relation to the origin, and that allows it to make it really easy for us to mate things, makes it really easy for us to make sure certain parts stay in space where we want them. Like if we move a hole on some other part, that part doesn't move with it necessarily. Like if we want it to be constrained in space, like we want our intake to stay the same distance from the ground or anything like that, we can do that easily with the origin all maintaining that same location in each document. OnShape, of course, is not loading well tonight, so that makes it a little bit trickier to do what I want to show. Why not? Okay. Okay, so this is the example robot for a couple other things later, but it's not. This is loading fine. Okay, there it goes. All right. So this is what I want to see. So this is the part studio. So this is where we actually create all of like these panels, any of the custom parts like these shafts. All of these custom parts are modeled in this part studio. So we can see all the parts for the indexer coming down here. This has some stuff that probably needs to be cleaned up, whether it was still an actual part or some things that aren't in the right spot. But largely it's in an okay spot. And we can see the origin is right here in the center. And that's the same as where it is for the whole document. We'll look at what in context assemblies are in just a little bit, or in context editing. And that's what all that transparent parts were the in context thing, so we could kind of see the rest of the robot. But this is how we modeled it, and we just make sure the origin is in the same spot in relation to our part. So we actually use that in context editing to let us model it all. And then when we come over to the assembly, we should be able to see it. This was loaded. Okay. We should be able to see that when we insert it, it stays right in the correct space. Maybe. We might be able to do that here. So if we hide the indexer here, and if I come up and I insert a new version of the indexer, one of the other things, I don't think I have this listed, but if you make a folder and you make a tag with your robot in it, it makes it very easy to get back to all the documents for the robot. So I can come up and go to indexer, and I can put the indexer in place. If I just click on it, it loads immediately, and it's in the right spot for me to then mate into if I wanted to. I don't want to do that because I didn't actually click the assembly. I clicked all the parts, which I definitely don't want. So I need to remove all those. We can insert again. So we can come back and show that again. So gamma ray, indexer. If I flip over to assemblies, we know we want to insert that indexer assembly. And when I put it in, it's already in the right spot. So if I can move my cursor and I can put it somewhere else, but as long as I bring my cursor back up over here, it's already there. It makes it really fast to mate, to find mating holes that I want. I could even like fix it into place if I need to. There's a lot of things you can do to just keep it in the right orientation to the rest of the robot without having to worry exactly about where it's going to be. OnShape just kind of does it for you if you model everything in relation to the origin. Okay. So how do we actually go through the top-down modeling and make everything kind of sync up? One of the ways we're able to do that now, and this is something we weren't able to really do on Gamma because we didn't know about this tool yet, and I was in like a earlier version. But one of the other FRC teams and one of the mentors on another team created a feature script, which is like custom code that you can run in OnShape. Though a lot of our other feature scripts are very handy. This one, though, it allows us just to use variables in multiple documents. So it's a variable library that we can create. So in our example robot, so if this was like our starting robot for 2022, one of our tabs in the 0 document, in that primary document, would be this variable library part studio. And all that would be in here is this variable library. So if you want to create a variable library, you just do it from your feature scripts down here. There's like a variable library button, and I can create one, give it a name, and I can add things to it. I'm just going to edit the one that I already have. So we have our primary variables document here. It says primary variables. And I can go in and I can add things like a ground clearance variable. So if I edit this in other documents, we could have it set how much ground clearance we want on the robot. We could set the length and width of the robot. We can set the height of the robot, an expansion limit. So like any global variable, things that we want, kind of that define the whole robot that might be used in multiple documents. Anything that like that can be in this variable library. We can also have a team variable library that's separate from any one robot document that we could import. So if we have things that like help us use the router or laser cutter better, so if you have like tolerances or gaps or certain things that you do for equations, all of those could be built into these variable libraries. And so you could store one, so we're not having to always like remember how to do something. We can just type in whatever the word is for it and pull out that variable really easily. To use it in another document, we can just import it. So it's the same way as before. You just hit the variable library button, use, and you select the part studio you're going to use it from. So in this case, we're going to do it from the variable libraries part studio, and hit check, and that's how you'd get that same variable library. This is the same one, so we don't need it twice. But then inside of it, we're able to use it. So if I edit this document, we have kind of our robot dimensions here. And a lot of times you don't want to, if in general, if you know you're going to use a dimension multiple times, or if it's something that you know you might edit, you really want to be thinking about the design intent of where do you want to have to edit that value and how often are you going to do it. So doing certain things in a variable library just because you know you might need to edit it more often, even if you may only use it once, is helpful. So you just know exactly where you can go change it. So you're not having to like find the exact sketch it's used in. So if I double click here, we can see it doesn't actually say the number. It just has the # length, and that lets it know to get that value from the variable library. If I come in here and I edit it, so I can make the robot be like, oh, we messed up. We need the robot to be a little bit longer. It's going to be 28 inches now. When I come back over here, it's automatically 28. So you can do the same thing across all of our documents, and we can keep those variables and those numbers in place. And if you edit the variable library once, it's gonna extrapolate out to the rest of the documents when you update it. So when it's in a different document, you'll have to tell it to update, which is fine. But it'll make it so those changes go out to all the documents, and we can keep everything synced together, which is what we want. Okay. The primary assembly. So the other part of that main document, which we already looked at, is our primary assembly. So this document's basically just going to have, or this assembly is just going to have an instance of each of our subsystems in place. We broke our model a little bit. There's an extra part here called steel plate, which was modeled somewhere else really quickly, and that's how we modeled the weight plate that goes on the bottom of the robot. Ideally, this would have been done properly in drivetrain and wouldn't have been here. So this should just have the 8 assemblies in it. That should be all there are. We have some different things fastened in place. There's probably some mates and things that we could have done better, because there should be a mate for each of these 8 assemblies, and there aren't right now. So some of them end up being fixed and things, which does work, but we may want to mate the origins better. It's kind of the same thing as fixing it anyway. Okay, so this document is what we consider like the main file, and this one needs to be what's actually functional and working. So preferably we'd figure out why there's just like parts sitting out here, and we'd get rid of those from whatever assembly they're coming from. So these are in the tower assembly, so ideally we wouldn't want those. We'd want to get those out. I think these might have been done like at Texas Cup when we were working on something, so we haven't cleaned them up fully. So this is the one that's viewable by everyone. For like our teams, we'll publish this version of the document, so this has the full robot and everything in it. The next part, and one of the ways that we did a lot in Gamma, is we have primary sketches. So we didn't separate things as well because we didn't exactly know what we were doing. We were still figuring it out here, but our primary sketches were in the same part studio as some of our block robot things that we did, kind of, which we'll talk about in just a little bit. But we have these sketches. We have a front, a right side of the robot. We have a top-down view of the robot. Then for this one, we also even have a back. So the back was basically just the climber sketch. And these let us define a lot of the geometry of all those mechanisms in a very simple kind of 2D way. Make sure things aren't going to hit each other, get kind of the generic sizing of everything down. There's not a lot of detail here. We know, like, okay, we know where the tubes are going to be. We know kind of where the rollers are going to be. We did some of the hood spacing. There's a lot of things that are definitely missing in this, but we're getting close to reasonable to where we know, okay, we can do enough from here that we can do the rest of the design. So if we look at like the left sketch, we can see all of these are a bunch of different spacings. We were doing some things in here to see like our actual like shot trajectories and hood angles. Some of these probably should have been multiple sketches. This probably, like a lot of this probably should have been brought out, but this allowed us to keep all the hood things happening right here. Some of the climb stuff, we were worried about like climb height, so we did some quick sketching to figure out if we could reach the bar. There's a lot of simple things that we can do in 2D that's allow us just to kind of like get a general idea of how we're going to solve the problems of building the robot without having to have real parts in place, real dimensions, gears, belts, any of that quite yet. We just have to be accounting for it while we're sketching, making sure there's kind of room for everything. But we don't necessarily know exactly how everything's going to work. So like even like the motor points, like where we're going to mount the motors for the tower, none of that's in here. We know there's enough space here to do it, and we kind of just left it at that, and then that was on to the person designing the tower mechanism to actually make sure it all fits. So that's kind of the goal with the sketches, to just give enough information that we're comfortable that the rest of the robot is going to work with what we're sketching and kind of how. So some of it gets more detailed, like in here, there's a lot of details into exactly how the hood should work, the compression to the rollers, belt paths got calculated in here. There's a lot of stuff that had to get calculated in this, so it probably should have been maybe its own sketch to keep it a little bit simpler, but it did work for what we wanted it to, so it was okay. These sketches get brought into the part studios. They get derived into the part studios. So we have this derived right here. So we can literally be using that to create our sketches. So this top-down view has where some of the wheels for the indexer is going to be. It has where like the shafts are going to be. And so we can use this whole shape and all these lines to model our parts and keep everything in place in relation to the origin. So this is one of the ways that we get that origin to be in the same place, because we're modeling everything off of these primary sketches. And that allows us to get everything kind of where we need it to be. Okay. From there, so sketching is definitely, if we only did one thing, primary sketches would be what we would use. Like that's by far the most, it gives like the most detail without too much work to sort of get an idea of how the robot's going to come together and make sure all the subsystems and mechanisms are going to be able to work together. One of the things we did in different ways, and we've kind of done, but not as much as I think we'll be able to do next year. I think we're going to use it a little bit more efficiently, is doing sort of 3D models that are kind of rough 3D models, or even just space claims. So you can kind of say, okay, this is how big this part of the robot can be. This is how big this part of the robot can be. And you kind of just make boxes, shapes, whatever, that are relatively fast, so that the people CADing the full mechanisms can know where they can actually put their resources and kind of where they can model things into. This can get a little bit more detailed and get into something closer to like block CAD or Crayola CAD, sort of like crayons. We have some of that in here. Let me see if I can show all the blocks, I think. What's going on? Oh, no, I just need to show parts. That's what I need to do. Okay. So we have this bit of the robot. So we ended up taking a little bit too detailed in some parts. So we put like rails going through. These don't necessarily take a long time to CAD, since these are just done with Julia's tube converter. These are pretty fast. There's a feature script for it, so you can even put holes in it and stuff. I think we were just messing around with the tube converter there. It's the only reason we put holes in it. But a lot of these other ones are just simple shapes that we can CAD really quickly and get an idea of how the robot's going to look. Like none of this is the real hood or rollers or anything like that, right? The shooter wheel's just a big cylinder. This can take, less than a minute to make any of these parts. Indexer, we probably took a little bit more time on. Briefly, we also, like, in the same folder, we have a few of the prototypes. So we actually had like a test indexer. This was the only part of Gamma that we really prototyped at all. So we CAD'd up a very quick prototype for it, and we're able to run that. And then we were able to use some of that prototype information to make this CAD and make sure we kind of knew it was going to work. This was a pretty critical piece to the actual robot working at all. So we wanted to definitely make sure this was happening correctly. It had some old ideas. So like this thing at some point we're planning to use this same shaft to control the control panel and like spin it in infinite recharge. That never happened. We never put a control panel mechanism on this robot. But that was the original idea. So some of those, there's probably a little bit too far out of scope of what block CAD is, but this gets you there. What we were able to do that we hadn't done with Gamma that we're excited about is doing more of just any of these generic space things. So here we have space allocation, so we can see this is the robot volume. So we could put this block just on top of our full robot, and we can tell if anything is at a frame perimeter. This right here is the expansion limit based on the rules, so you're only allowed to expand so far past your frame perimeter. So if we could put this over the robot with the intake deployed, and we could see if our intake is too far out. Are we reaching past how far we're allowed to reach or not? And we don't have to sit there and try to bring back specific measurements to the end of a roller or to a belt or whatever we're trying to measure to. We can just see if it fits the volume that we're constrained to by the rules. So things like that are really simple. We can add some details to this if we want to limit the volume of the robot in certain areas. Maybe we could, exactly show where the intake can't be, so we could like block off some room for the indexer and say, okay, the indexer is in this space. The intake needs to make sure it's not violating any of the indexer space before we even CAD the whole indexer, right? So it allows for multiple people to be developing parts of the robot without having to wait on any of the other parts of the robot to be finished. If we can kind of specifically say this mechanism has this much space, this mechanism has this much space, we can go a lot faster and get our work done without sort of waiting and having any communication problems or people wondering exactly what they can and can't do. We can kind of do that with the definitions that we'll be able to set up in the main robot document. Okay, so recapping kind of what goes into a primary document. So our primary document is going to have our main assembly. It's going to have our variable library, or our primary variable library at least. It's going to have our primary sketches, which is going to be at least 3. You probably need at least a top, front, and left, but you can probably have extras for more specific sketches for certain mechanisms. If you want to do them in the primary document to make sure they're interacting with everything else properly, like we did with the climber. So multiple is fine in there. And we're also going to have our space allocation document, which may or may not include also, and you may also have some version of like a Crayola block robot as well. So those might be separate documents. Anything like that, just so you can get a more 3D picture of exactly what the robot's going to look like without having to do a lot of the detailed CAD yet. So it allows us to speed up the process, make sure we're not going to figure out where things are going to hit, interfere, all the packaging problems where we're trying to fit all the stuff together. If the more we can work out early on in these like primary, simple, easy to use, easy to change documents before we do the details, is going to make our season a lot better. Okay, so how do we actually use these? So we talked about Derive briefly when we were talking about the sketches. And this is one of the places where going through and doing that top-down modeling learning pathway is really helpful. It shows exactly how to use Derived everywhere, exactly how the tool works. They do a really good job of training you how to use the Derived feature. But the main idea is that we were just able to import those sketches wherever we need to. So like I showed here already, if we come in and we can edit this, it'll show you what we're grabbing. We're having to grab these sketches. Preferably in the future, our main robot will only have the primary sketches in that document. We don't want to have all these other parts and things to make it harder to find what we need to derive in when we just want the sketches. So hopefully that'll all be done a little bit easier and more organized for us on our future robots. But you just select the sketches and they bring them in already in place where we need them to be. They bring them in here, and then we can use those sketches in any of these entities to make new parts as we need. And that makes it really easy because you're not just trying to create something out of nothing. We have this like base idea of what the mechanism is going to be already. And then we just have to put in all the details, getting in bolt holes and slots, and all the final CAD to make it actually a buildable robot, and not just these like sketch lines. The second thing we can do, because the sketches aren't always enough detail, so the sketches and those space allocations are going to be a lot of detail, and they're going to help get every mechanism started. But as we get closer and closer to being finished, all of the mechanisms kind of need to interact with each other, where you have things mounting to each other. You want to make sure you're exactly not hitting something else. Nothing's crossing, nothing's taking up an area. You don't have intersecting parts where like two volumes are trying to be in the same space. So to do that, we use a concept that we actually started using back in SolidWorks, but we moved over to here, called construction assemblies. So this assembly is never a final product. We're never going to import this assembly into anything. This construction assembly exists just to help us construct the parts in our mechanism and in our part studio. So Indexer's construction assembly is here. And we can kind of see what it looks like. So basically what a construction assembly is we just make a new assembly in the mechanism document. The first thing we import is the entire main assembly from this document. So it's a little bit weird because there is a version of Indexer that we're also importing into here. But this version of Indexer is only whatever the old version is that we've versioned and then imported into here. So it's kind of recursive. There's a bit of a loop that happens, and you can kind of get into a versioning loop if you make some weird references or something. So most of the time we'll come in and we will immediately hide this version of Indexer. We don't want to see this in this construction assembly. We only want to use our fully updated Indexer, which we're going to import the one from our part studio. From our part studio, we're going to insert no, sorry. We're going to insert our from our assembly. We're going to insert the full assembly into this assembly. So now we have this indexer. This indexer is the one that's directly attached here. It doesn't need to be versioned ever because they're in the same document. So it's always updating. If I change something over here, which I don't think there's anything I can change easily, can I drag something around? So if I drag like this pulley around, it should. Oh, it's not. It's fixed. That's why I have to like ungroup it or something. There's a way to make it update. I'd have to go through and do it. But basically, it'll update faster and work the way it's supposed to. But the biggest thing it lets us do is allow us to edit these parts in context in our Indexer Part Studio. So we have these assembly contexts, and if I come in and do construction assembly as the context, I then get to see a lot more of our actual robot, and I can reference to that if I need to. So we can sketch, put dimensions and things from it. Allows us to make sure things are actually attached into here. So like all of these hole patterns, we were able to just use the poles directly from the tube that's behind it. So like the tube that's behind this has all these holes in there. So we didn't have to try to get the dimensions and model them, or have to do something else to where if I move the holes on this tube for some reason, the holes in this plate will automatically update. And so that's what we always want to worry about when we're talking about design intent. If we know there have to be holes on the front of this, the holes in the front of this they're not in like specific points to anything else but the holes behind it. So we want to make sure we're like using that geometry. So if we ever update those holes, or if it moves, we want those holes to move and update as well. And it just saves us a lot of time, saves us headache. We don't have to make parts over again in case we got one of these hole positions wrong. So the in-context assembly, allowing us to have access to actually seeing the physical parts of the other parts of the robot, is super useful. So if there's something else we needed, maybe we needed the actual tower. Let me see if it'll load fast enough so I can do this. Maybe not. Okay. But yeah, so we shouldn't use in context for too much stuff. Ideally, the best thing it's used for is copying over hole locations, copying mounting locations, making sure things aren't touching. You don't want to dimension off of other things too much. It does get a little complicated. It'll slow things down if you're always just sketching on top of things that were done in context. But specifically, copying holes and mounting locations is a really good use for in-context assemblies, and then just generally seeing that your entire mechanism is fitting on the robot the way you want it to. The set primary instance function lets you see where it allows you to update it allows you to keep the part studio in context with the assembly, even if you like delete an old part or something. You can make it still work and know where the primary instance is, which is super helpful. If I go and show something like tower in here, if I come back into Index or Part Studio, I can update context, and it should show me the tower in here as well, if I did that correctly. Okay, while it's doing that, we can move on. Okay, so recapping the document, and we can double check that that worked. Each document for a mechanism is basically just going to have its main mechanism assembly. It's going to have a part studio where you're modeling most of the parts in, and then you can have multiple part studios. So it's very possible that you need more than one part studio to get the parts made in a reasonable way. Sometimes we've had parts that we knew we were going to make duplicates of, or maybe they need to have a bunch of configurations. Anything like that, if you're having, especially if you're putting configurations on a part or something, you don't want to do that in the main mechanism part studio. It gets really complicated. If there's things you're experimenting with, something that you're not quite sure is how it's going to work, you probably don't want that in the main client, in the main part studio for that mechanism. But any just kind of generic shape, things are going to be modeled together and need to be referenced to the rest of the robot, plates, tubes, any of that sort of thing, we can model in the main part studio for the mechanism itself. And then they're going to have that construction assembly. That's basically just how we can reference back to the entire rest of the robot inside of our part studio when we're modeling, to make those mounting holes easier, to make any final fit checks easier, without having to go and open the main document, or trying to edit anything in a weird way. It works pretty well for that process. Okay, so Indexer did get it fully updated, so now we have the whole tower in here. If we needed to check how some of these support rails and things, like exactly how close they're going to be, maybe we're moving something out and we want to see how close this rod would be, we can get that dimension and make sure we're not hitting it. Same with any other parts of the tower, we can do the same thing with. And it is a little bit tricky to see sometimes. It's not the easiest. But it works pretty well for what we need it to do. Okay, one of the final pieces to letting our whole robot work is, in addition to the MKCAD, which is how we get most of our parts into assembly. So if we're over in our indexer assembly and we need a new wheel or something, most of the time we're going to use MKCAD to do that. Maybe we will use MKCAD. Okay, so we could come down and we could get some specific wheel that we wanted out of MKCAD, and we could just put it in our document really easily. Maybe we needed a 2-inch mechanism wheel for some reason. We can go ahead and insert that, and it should load up on the origin for us, I believe. Maybe I should have used a simpler wheel. Okay. So while that's loading, oh, there it goes. Okay. So yes, now that wheel's in place. It's normally a little bit faster than that. That was one of the slower times it's taken. It might be because I'm streaming. You can grab that and put it in and mate it to wherever it needs to go in our assembly, and it would work fine. But the MKCAD doesn't have everything we need, so there's a lot of times there's parts that we make specifically, or there's things that only we use. So some of the times we'll have our own part library. So inside of our 3847 general folder, which is just the main folder that gets shared with everybody, we'll get everybody's username, make sure everybody has access to this. We have our own CAD library for our parts. So there's some parts that are kind of experimental stuff, some things that we've just been working on. But one of the things we do have is like spectrum COTS parts. There's ones that don't make sense necessarily to be in the full MKCAD or things that we've made ourselves or kind of edited, but they're things that we know we'll use on multiple robots. So this is like the camera module, and it's not a perfect camera module. It's an approximation of one that works well enough for what we need it to. We make some versions of the simplified motors and things that are a little bit different than some of the ones that MKCAD has. We made like a simplified swerve. Some of these things just help the files load faster if we don't need the full geometry of having like the gears and pulleys and everything. We just need enough to make sure our stuff's not hitting anything. This does a pretty good job of that. I think our simplified RoboRio, we added the zip tie cutouts because they weren't on the other one, and we use those for modeling where we're going to zip tie the RoboRio down. There's a few other things, like we have specific solenoids that we use that not a lot of other teams do, so we make sure we have those. Anything like that, that's things that our team uses that not every other team does, or sometimes there's not in MKCAD yet. So I think when we were modeling it, this chain tensioner wasn't in MKCAD at the time, but we still needed to put it in our robot, so we'll put it in our CAD library instead of directly adding it to any of our part documents. So in general, or our mechanism documents. So we shouldn't really be adding any COTS parts to our mechanism documents directly. We never really want to come in here and do import because it just gets confusing where that part lives and how we access it properly and anything like that. So if we're going to import it, we want to do that into one of our part libraries that we have somewhere in here. So maybe you have to make a new one if it's some part we created, or we would add it to one that already exists. Spectrum hardware is a little bit different. So this has some of the bushings and bearings, tube connector nuts, things like that that weren't in MKCAD, at least at the time. It might be now. MKCAD's always adding stuff. But little things like that that we may need to include in our robots. It makes it sometimes faster just to get the certain nuts and bolts that we use that may be in MKCAD, just may be harder to find. All of those types of things are here in our document for us and relatively easy to get to. And we'll expand, and they just allow us to keep adding them, keep expanding them. So it's better to add them in here once, so then if we use it on multiple robots or somebody else needs it on our robot, we can all benefit from the work of the one person who had to actually do the imports and make sure everything worked right. Okay. So that's pretty much the process that we go through to organize and make sure the robot's working. A couple things, since we have a little bit more time, that we would normally do in other ways, but some of the things we do to also make sure we can help edit and organize things. There's a few things that are useful. So one of the plugins that exists is called like Link Tab, and it lets us put some of our Google Slides in ways that we like organize the robot outside of OnShape into OnShape. So this is our design sheet, which we'll go over exactly how the design sheet works. At some point, I need to make a simpler version of it. This got a little bit too big and complicated, but it has a lot of really useful calculators and tools. So this helps us figure out exactly how the mounting for pneumatics works and how long they're going to be and what options are available. The mechanical tab has so many things for how to calculate like chain and belts and everything. And so we can do this right here if we need to, if we don't have another tab open, or if we forget where the link is or something, it's already here ready to go. This slide or this tab should be our Google Slides presentation where we keep all of our design slides. So this is how we as a team organize a lot of our like group thoughts on how the robot works. These are also cool to go through if you weren't on the team when we were designing these or you weren't part of the process. Going through and looking at these is pretty neat. You can see like where we got some of our ideas from. So this is 125's robot. This is partly how we modeled some of where our intake came from based on theirs. They had some other geometry, but it worked out. Indexer, tower, all of these things we were looking at different ideas for how to make this robot. You can see like kind of where it started. This is some of the block CAD that got there, and this goes all the way through pretty large chunk of our design process until we're really right at the pretty close to the end. We're figuring out like some exact changes here towards the end. The other features of OnShape that are super useful are our ability to comment on things. So we can leave specific comments with how to fix things if we have certain problems. This is one of the ways that I review a lot of stuff for the various people working on the different mechanisms. So we have like to-do lists that can get assigned out, so I can tell people exactly what they should change. Or if you see something that's interfering with one of your mechanisms, or if you just come in and you're helping somebody and you leave some comments on what got done, it's really useful to be able to do that and see kind of exactly what needs to be changed. So you can actually even like leave a comment. You can draw boxes and things. So I make a new comment here. I can mark up some section of the robot. So maybe we remembered this is actually a problem still on the robot. There's nothing connecting this tube at this angle, so this whole thing can kind of flex, which is a bit of an issue. So we could come in and like point out here, maybe we could put like a square there or something and be like, hey, we need a bracket here. And you can assign it to different people. So if I could tell like Felipe to do it. He was working on parts of this stuff back there. You could tell whoever you want to do it. So that type of thing is very, very cool and powerful. If you at somebody, they get notified that there's something they should look at. So I'm very excited to be able to do that throughout build season. We'll be able to go a lot faster since we can kind of always be reviewing the work that's going into the robots pretty constantly. There's no one else in this document at the moment, but you can also follow people, which is really cool. So you can watch people as they're CADing. So you can double click on their little icon and it'll show you what they're looking at. So you can see what they're modifying at the time, make sure you're not modifying the same thing. Anything like that. And as you're going, you can kind of see what they're doing and see the progress they're making and things, which is really cool. Okay, I think that's most of how we do this. And again, I would definitely recommend going through the learning pathways on top-down design. They're going to go through exactly how those different tools work. They talk about space allocations. They talk about primary sketches. All of those types of things they walk through and have a good idea of how it's used too. So this is a practice that's used in industry. It's used for how people are designing things in their actual jobs. And this is just how a lot of big projects get done in CAD.